Hi, I have a question. This is a simulation that is on a video from Vsauce, specifically how Earth moves. But I'm going to focus on this one specific section here, which asks a question or two. So basically, this is how the Earth travels around the sun, and how the Earth and the sun travel around through space. Essentially how the solar system moves through the galaxy. And if you notice, it's going along this kind of path. So this asks a specific question. Does this prove that time travel is impossible? Well, let me ask you this. Suppose you got into your blue box or your DeLorean, and you go in with that 1 minute experiment where you go 1 minute forward in time. What exactly happens to the world while you're moving in time? It's not like these movies often make it seem as though you go from here to here instantaneously. But no, you're actually stepping out of our time continuum for a minute, an hour, a year, a decade, a century, or what have you, right? And you're returning back to that original point. So you move in your DeLorean by a minute. That minute is now with the Earth rotating. Now, offhand, I don't know how fast the Earth rotates in comparison and how much distance you would travel in a minute. But let's say you get in your DeLorean and you zoom away 88 miles an hour, and then you come back 1 minute later. The Earth is rotated, let's say 10 feet. So you're 10 feet over there. And not just that, but you're also moving through space. Now, depending on where you are in regard to how the Earth is traveling, maybe the Earth would be in relation moving away from you. So you'll be like maybe a foot up in the air. Or essentially, if you're on this way and you're moving that way, maybe you'll be a foot in the ground. Or some derivation therein, maybe a foot like there, I don't know. But that's the question mark, isn't it? So that's what this tells me. That you have to take into account the motion of the planet. So if you go and say, time travel a year. Let's say you're going a year in the past because you want to go and see that amazing Super Bowl again from last year. Isn't that a year when the planet was over here? I mean, you're here, but the planet was way over here. So you wink out, you come back, you're now sucking vacuum because the planet's no longer there. You go back in time, the planet is still way over there. And vice versa. If you say, oh, I want to go a year in the future. Well, a year in the future, the planet's going to be over here. But you're here, you come out, you come back. You're dead. Well, what about if you use a wormhole? Okay. See, I remember in college hearing something about that. And I could be absolutely wrong. I'm going by memory from when I was in college years ago. You have a wormhole here, you have a wormhole here, and that essentially allows you to go through space a lot quicker. But if one end of that wormhole moves in relation to the other end, that's where you get that time travel effect. But this is moving already. So aren't you all, and this end would be moving and this end would be moving. Now maybe you could have it moving in the same relation, But is it always going to be a perfect one-to-one relation? I mean, how can you make certain that the speed and direction exactly matches over here? So you're always going to have that time travel effect. If anything, you would probably have like one of those Stargate apertures type of thing. This one says, June 1st, 1980. This one here's August 10th, 1990, and so on. That would be the case. So yeah, does that mean that time travel in a lot of what the stories are impossible? Now you could say, well, you have the momentum, conservation of momentum, because if you wink out for a minute, you have the momentum of the planet. You're on that planet, so you're having that momentum. So maybe that will carry you forward. So, okay, instead of that, you're off by 10 feet, you might be off by 9 feet instead. Maybe it might carry you a little, but definitely not if you're a year or 100 years or 1,000 years. Now, I don't see how that could be. And especially since this is rotating. I mean, if you were going straight here, like on the sun trajectory, maybe you could say that, but this is going around, and also like, this is if you're in orbit or if you're on the surface and you kind of, it's wobbling, but you're still, even if this is a straight line, you're still going around. So you may wink out here and come back, but now the Earth is over here. Well, now how's the Earth? And you get momentum is in a straight line. It's not in an arc. You put a rock on a string and you're going like this, circling, and yeah, it's going like that. But once you cut that line, it'll always go in a straight direction. So that's what this tells me, that time travel is impossible, right? This picture also tells me something else. If we were able to have a satellite taking pictures of our solar system, that it's just parked in perfect geosynchronous orbit, following us in parallel along this. To me, couldn't this be maybe a trail of oxygen atmosphere particles? I mean, yeah, our gravity helps, and our centrifugal force helps to keep the atmosphere stayed on, but I would think that over time, even if it's molecules per year, we would have a little bit of a trail, wouldn't we? So 1 billion years ago, wouldn't we say, and I'm making up numbers because I have no idea, I don't think we can know any way of actually quantifying it. Let's just say 100 gallons worth of air molecules of various, over the last 1 billion years we've lost. And so if we were able to take a picture, we could see maybe a trail of where, if we could just take a spectrogram of where we were, we would have a little trail, oxygen and nitrogen and all the other airs, ozone, wouldn't we? I mean, I don't think there's a way we can fix that. I don't think it'll become a problem for another 10 billion years, maybe, when we'll be long dead before it becomes a problem. But I'm like, this is what I think of when I look at that. Anyway, I want to thank Vsauce. They're a very good website and good YouTube series. I recommend watching it. I learn a lot watching this guy. Anyway, I like to hear more from you guys, what you think, and that's why I'm posting this. So thank you very much.